Good afternoon, everybody. So this session is about how to use ProxySQL for inexpensive data masking. So first of all, who we are. There are two persons listed here. The reason behind is that, well, I will show you, I will tell quickly. So who am I? I'm Rene Cannao. I'm founder of ProxySQL. My background has been in database for quite a long time, 15 years or something like this. And currently, I'm also being MySQL SRE at Dropbox. This presentation has been similar one has been presented also at other conference together with Frederick Descamps, that is MySQL community manager at at MySQL, so at Oracle, and a lot of the work done here is his job. So I think it's fair to thank him. So here he is. So there has been another two sessions, one from Alkin just 2 hours ago, and there was a meetup yesterday about speaking of the proxy yesterday, organized by Peter Sviat from Percona. Okay, so this is our agenda for this session. I will do a quick overview of what are the problems with MySQL, with the database systems, then what is ProxySQL, what are the features in ProxySQL, not all of them, just a very quick overview. And then we're going to dive in the specific topic of this session, that is data masking. So we are going to discuss why data masking is used and how to program ProxySQL to do the masking and data obfuscation. And of course, then there will be a bunch of examples. So, quick overview before ProxySQL actually of database overview. I don't know how many DBAs there are here, how many developers, but the problem I'm seeing in my many years of experience is that the system where databases are deployed is a layered system in which you have the application from one side and the database from the other side. And I thought there is a very common and very declarative API, so the application communicate with database making requests. You normally don't have much control of what is going to hit the database. So, I mean, you can be the DBA, you can tune the database system as good as you want, configuration, but optimal configuration, better use of the hardware you have, creating some load balancing, creating high availability, and so on. So you have this part covered, but you have absolutely no control from what is coming from the application. And this was my problem for many years. So this is from where the idea of developing ProxySQL came. So what I needed was a tool that was able to empower me as a DBA, but also, of course, other DBA, and to have this layer that is able to understand the traffic from the application to database and take action. And action is, of course, before taking action, it has to understand the traffic and being able to transform the traffic coming from the application. So in another way, creating a layer of protection to the database. So those are the main motivation, and basically the idea was to create something like this. You have the application that communicate with this layer of proxy, and then the layer of proxy will query the database system. One thing that I want to highlight is that this layer is, in my opinion, should be a reverse proxy. So this is what ProxySQL does. It's not a forward proxy like HAProxy, because in HAProxy you have the application sending the request to HAProxy, and HAProxy has no idea what the request is and just send the query down to the database server. Instead, here, if you have a reverse proxy, the application is sending the request to the proxy, and then is the proxy that will take care of identify where this request has to be sent, and basically get the data and or not get the data, depend, might also block the data, or transform it. And this is exactly what we're going to present in this session. So what is ProxySQL? I like to define it as the MySQL data stargate or gateway. So basically everything has to pass from the proxy, and then the proxy will take care of sending to the right place and transform the traffic accordingly. How to deploy it? I put here two slides just to have a picture of how things should be deployed. You can two common setup. You have the proxy installed in the same application server, so the application will always communicate with the proxy locally, and then the proxy is responsible to find where the request has to be sent if it has to be sent at all, because it might be possible that the request is cached, or it might be blocked or rewritten, and so on. This is one example. This is another example in which you have a silos approach. So you have multiple servers communicate with one proxies. So create some silos. Group of application server that communicate to one single proxy, and then this single proxy is responsible to reach the right database server. Okay, here there is a non-exhaustive list of features in ProxySQL. The real list of features is way longer, but here I want to highlight what I think they are most interesting features, and I also put on bold the one we are going to discuss during this session. This presentation probably won't cover 1 hour, 45 minutes, so my idea is to have a longer Q&A section. So if you have any question about one of those topics, just please memorize it and ask question later. So the one that we're going to speak specifically are on-the-fly rewrite of the query, firewall, and data masking. But of course, has other features like caching, connection pooling, query routing, load balancing, real-time statistic. This is very important because it actually collects statistic of all the traffic that's passing from the proxy. Support for various clustering solution and the scheduler, and something very interesting is the ability of being reconfigured on runtime. Okay, a couple of slides before I was saying that it was the MySQL Gateway, but actually it is improving and evolving a bit more. So right now ProxySQL is also able to have different type of backend, and specifically it can communicate with ClickHouse. So who knows ClickHouse? Perfect. So maybe I can spend 30 seconds more on this subject. So if you're using ClickHouse, you have your application that need to be that has to use some library to communicate with ClickHouse. And so if you have a legacy application that knows only the MySQL protocol, you cannot communicate with ClickHouse directly because you have to use some different libraries or rewrite part of the code. The idea here behind this is that the application doesn't need any changes. The application will communicate with ProxySQL using the MySQL protocol, and that will be ProxySQL that will convert the request in ClickHouse protocol. So send the request to ClickHouse, ClickHouse will process the query, return the result set, ProxySQL will take the result set, convert it into a MySQL result set, and send it back to the client. So if you are using ClickHouse and you are planning to change your application to start using ClickHouse, you should look into ProxySQL 143 that has support for ClickHouse. And then it also supports SQLite as storage engine. Okay, so why you want to do data masking? There might be different reasons why you want to do data masking. For example, if you want to generate some data from your database and you don't want to export the real data, but you want to export something that is close to it. For example, if you want to hide the identity of some person but shows the first 2 letters. Or for example, if you have credit card information and you want to only export the last 4 digits of a credit card. So you don't want everybody to have access to this information. Of course, you can implement things in the MySQL server, like using view and so on, but you can also do it externally using ProxySQL. And this is also very interesting if, for example, you have developers and you want your developers to test the application on some result set that is same size of the result set of production, but it doesn't have exactly the same data. So this is a way of exporting it. So we're using ProxySQL for this. Well, first of all, it's open source, and I think this is already a good point. There are other solutions. It's not the only solution. There was another one that was Green SQL or something like this. But normally, all the other solutions are either very expensive or not working. Sometimes both at the same time. So yeah, you can use ProxySQL most of the time and you will get good result. It's not perfect. You will see later on exactly how Datamasking is implemented. So you will understand that it's not a perfect solution and there might be way around it. But compared to what there is in the market is not worse than the other one, so why not? The best solution would be, of course, to implement these features in MySQL itself, so in the handler API. So it will be MySQL itself that does the transformation, and this will be the best solution because it's the safest solution, and because MySQL actually understand better what is the query and what is the data that is being accessed, so it can perform all the transformation and the data masking there. Okay, so at the very core of how ProxySQL works, there are the query rules. Query rules are nothing more than a set of instruction. So it's a way of programming the proxy. So they are defined in a table, and you have some columns that define matching criteria, like the username, the schema, a regular expression on the query or on the pattern or source IP and so on. And then you have action. So you can tell the proxy, every time you're seeing a query that matches the specific traffic, take this action. And the action could be cache it, send it to the specific host group, or kill the query if it runs more than 5 minutes, and so on. Or it can be rewrite. And this is actually what we are going to show now. And another important thing is that you can have one queries that matches multiple rules, and the way of matching multiple rules is using some sort of flow control in chains. So you can create rules that are followed by other rules, so the query is being processed one rule after the other. This part is clear? Yeah, perfect. Okay. So this is how the query write happen. So you create some rules, and the ProxySQL will know that every time it sees a query that's match a specific rule, it has to rewrite it. The interesting thing is that it's done completely transparently to the application, so the application doesn't even know that the query has been rewritten. The application just sends the original query and get what it believes the original result set, and of course it's not. And it's done on the fly. So while the query is passing, it's being rewritten. And if you are familiar with regular expression, what it does is something very similar to match and replace. Perfect. So, so here what we are going to do is we're going to do something like the user send some statement, and we are going to rewrite the statement, either putting some X where, for example, if it is a name, and we'll basically transform the result set. There are two approaches to data masking. One is to alter the result set, and another one instead is to use MySQL dump to get a dump of the database, and the dump in reality has obfuscated data. Okay. Yes, I already did this. Perfect. So here is actually an example of how things will look like. So assume the user is executing this query, and this is the original result set. And if we create some regular expression and some rules, we tell the proxy to rewrite the query. So the query that is being sent to the database is not the original one, but is a rewritten one, and the result set will be this. Okay, so instead, for data obfuscation, instead of putting some X, what we will do is the query is the same, and instead of getting some data that is masked, like putting the X in the name, what we are going to do is, instead of using the same birthday, we put some random number there. So from if we take this data and we give them to the developers, they get valid data because this is a birthday, but it's not the original data. So the developers does not have access to sensitive information. So, okay, let's start and see how to actually configure ProxySQL to manage this. ProxySQL is configured through tables, so it has a database internally. And if you want to create some user that has access to ProxySQL, you actually have to create a user in ProxySQL admin interface. So in this case, we are creating two users. One is the user called the developer, and we create another user that is called backup. Nothing complicated. Once we have done this, this means that now we created 2 new users that can connect to the proxy and execute queries. So there are, of course, as I was saying before, it's not a perfect solution. So there are some certain queries that need to be avoided because they are just too complex to handle. And so for this specific example, what we are going to do is every time a query has a select star or any sort of variation of it, we are just blocking it, and we will return an error to the client. So the client will get an error, something like you cannot execute this query. You can customize the error, and we'll see soon how this is exactly done. And again, for the obfuscation, what we are going to do is, in case of first name, we are taking the first 2 characters and replace everything else with X or with random strings, depend. And this creates some complication because soon I will show you how the query is being rewritten. But what is important is that once the query is rewritten, the data definition that the client gets has to be the original one. So if the client executes select first name from table name, the result set that we send back to the client, even if we modify the name, the data definition should be last name, cannot be something else. So we have to take this into consideration. Okay, so now we're going to have a view of all the query rules that we are going to use to actually perform this operation. There are actually 7 rules to do this, so it's not an easy task. So first of all, we create a rule. Every rule has an ID. The rule is active. This rule is only for user level. So if this proxy is used for both development and production, and the production user is a different user, the production user won't be affected, and is only for the schema name employee. So the first rule, what it actually does, it replaces all the queries that has backtick multiple time and first name with just first name. So this was the first a way to avoid that a user try to avoid the regular expression, putting a lot of backtick and just bypassing those query rules. So this is the first transformation. And here we have apply 0. This means that not that the transformation is not done, but apply 0 means that this is not the last rules that is being processed. If you're familiar with IP tables, you know that IP tables, you can have multiple rules one after the other one. And if you have a /j, you create an action and you actually exit from the chain. You can exit from the chain. So basically this apply 0 means do not exit yet. So the second, maybe you should pass from the other side. So this is used to replace queries like here if you have backtick multiple time or just once or not at all, and then you specify a table name dot first name, this regular expression will rewrite it and be only first name. And this things is also take into consideration the fact that you might have a space after first name, or somebody can put a /n, so going a new line. So this part is being rewritten as well. So it rewrites as a concat of taking the first 2 characters of the first name and then replace everything else with a series of X. Now, while showing all the rules for the first name, I actually here want to show a rule for the salary. So again, here we apply the same principle. So if there is a table name here, dot salary, this part is completely discarded. So only salary is taken. And instead of replacing the salary with the first 2 digits of the salary, because you cannot do this unless you convert the salaries in a string, but probably you don't want to get the first 2 digits of the salary, because depending from the salary range, you can actually understand pretty much what is the salary. I mean, maybe nobody cares about the last 3 digits of the salary. The first 2 are what are relevant. So instead of taking the salary and doing some transformation on it as a string, what it does is create some random number, it multiply by 50,000, and then it does 10,000. So it creates a valid number. Maybe it's completely out of range, but it's valid number. And here there is a concat with space. And the reason why there is this is so the number is converted back to a string and is sent to the client. Something here interesting is that, as I was saying before, no matter what is the query that we sent to the database server, the result, the column definition should be the same. So we're actually adding salary at the end of the write. So this is aliased to salary. So when the client gets the result set, in the column definition will be salary instead of having this long concat and this random generator. Make sense? And we are still at the beginning. Okay. So what is this used for? Instead, this is used for to avoid things like if you have concat first name. So if you have concat first name, this is handled nicely because the first name is being rewritten, but you need to avoid the concat part. So this replaces the closed, not bracket, this symbol, I can't remember now the word in English. And then if there is any word after this, it's being copied by the regular expression. And then this one, it avoids the fact that you use something like first name, then a space, and then you put another word. So it's actually get rid of this. So those rules are applied one after the other to modify the original query until it reaches the last one. Okay, so we had all those queries, and let's assume that now the developer is actually sending some queries that is like select a number of space, and then there is a star. So this is select star. And we basically will create the rules that says that we tell the proxy every time you are getting a query that is a select star, just return this error to the client. And not only this, but we can have something like, well, user can get a bit smarter. So instead of using select star from the table name, they can specify select table name dot star. And also in this case, you get an error message. This should have been rule 7. Okay. Again, this is a way more complex scenarios in which you have select star from employee as blah, blah, blah. Every time you're seeing something like this, it will just return an error. I have seen cases in which some ProxySQL users, what they did was something like they created a whitelist. So and they create one rule for every query in that whitelist. So if the user was executing a query that was allowed to be executed, was getting the result set, otherwise it will just getting an error. So everything that was not allowed to is automatically rejected. There is any question on those rules so far, or I can pass to the next one. Okay, perfect. So next things. So those were to handle live queries, so the developer executing some sort of query using their application or connecting directly to the proxy. It has some limitation. The best way for a completely different type of problem is if you want to get all the data from the database server and use this data to provision some testing environment where the developer can actually execute some query and test their new application on some data that looks like production but is not real production. So for this, we can use MySQL dump. And this actually makes things a lot easier because you can create rules that transform the original query generated by MySQL dump in whatever write you want to execute. So to make an example, let's assume that we have these rules this rules is it match only the query coming from user backup. And I don't know if you ever saw the queries that are being executed by MySQL dump. Probably yes, if you had some long-running queries, but they're very simple. They are select blah 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 from table name. They're not complex at all. So the way you want to replace this is, instead of a select star, you don't want to have a select star anymore, but you want a select. You list all the columns that are in the table name, and for one specific column, like for example the salary, the real salary, you just create some random number there. Something important here is that the number of columns should be the same and in the same order, because otherwise you are not able to import the dump. And this is for salary, and this is for the employee table. So again, number of columns should be the same. Here we simplified. We just replace star from table name, and the number of columns should be the same and in the same order. To note here is that we don't put any alias. We don't need to, because MySQL dump just get the dump, and then when reimported, it doesn't need the column definition. The column definition is taken from the show create table, so we don't need the column definition in the result set. Also, because this result set, what it creates is insert statement. Question here? Okay, I'll go forward. Limits. So I have been work a lot with Fred, because this thing was not easy to get implemented right, because in ProxySQL before version 1.4, only one type of regular expression was supported. That was RE2, and it doesn't have the global attribute, the global modifier in regular expression. So if you want to modify something in the string that was the query, it was going to modify only the first occurrence of the pattern. So if you want to modify multiple occurrence of the same string, like select the first name, comma, first name, and so on, you had to create some loop that ProxySQL 1.3 supported, but it was just too complex to create rules for this. So in 1.4, also the per regular expression were introduced. So now you have two types of regular expression engine. You choose the one you want. And for this sort of operation, what I recommend is to use the per regular expression. They are slightly slower for certain type of query. I did some benchmark, actually very interesting, depending from the type of query. Sometimes one regular expression engine is faster than the other one. So I cannot say that one is faster than the other one, but it really depends from the query. Another limitation of the implementation we had of the rules I showed before is that the transformation will apply to whatever table you have. It doesn't matter with tables, because it will apply the rules in this way, and the table name will be stripped out. And as I was saying at the very beginning, regular expressions often are not enough to perform complex transformation. So this is why I was saying that ProxySQL might be not a perfect solution in all scenarios, but it works quite well. And you can go for the safe approach that whatever doesn't match the rules that you have created, just block it. And of course, the dump solution seems to be the best if you want just to take the data and provision it somewhere else. Okay, because those rules are quite complex, Frederick actually wrote a very simple shell script in which you specify the columns that you want to mask, the table name and the schema name, and the script will automatically generate the rules. So you can take the rules and send them to ProxySQL. So it will be created there. Here is the link from where you can get this small shell script that generates the rules. Okay, here there is a list of examples that those rules are able to process. So if user sends select star from employee, this query is just being dropped. If a user sends this type of query, the first name is being replaced with the first 2 digits and then a series of X. There is the example I was saying before with the concat. Here there is a concat with nothing, so at the end it will be still first name. So there are those rules that also try to that cover this specific scenarios. And then you have scenarios in which you have table name and schema name dot table name. This is covered as well. And then you have scenarios like this one that need to be handled as well. And it also handles scenarios in which you have multiple backtick and not just one. This is supported by SQL. This is handled as well. Then there was this specific case, very interesting, in which here you have a new line. Originally this was not supported, but somebody came with this as a way of bypassing those rules. So this came as a very interesting experiment, as a blog post, like try to break through this. And some people became very creative about how to break through. And of course now this case is also handled. Here another series of examples. So this is handled as well. If you have first name as an alias, the query rules that I was showing you before, it also handled this scenario as well. So first name is replaced with a regular expression, and instead of replacing with first name, it replaced with the alias. Here you have the same replace and the same alias, but without us. This is very interesting. So you're actually using the keyword as the alias. And okay, this is handled as well. Yeah, I mean, people get very creative in how to try to bypass the rules. And yes, here there are a few more, like here, for example, this one, it doesn't specify select the employee tables, but a.star. So here it is using a table alias, because here you have employee. The employee table has an alias as a. So this one, now there is a rules that whatever is there, just block it. And also cover the one with the comment at the beginning. Initially was not handled because everything has to start with select at the very beginning, so it was just enough to put a comment to bypass the rules, but this is handled as well. These two with a comment with the first name inside the comment, handled as well. And I think we are done with the example. So if you manage to pass through those rules, so to bypass those filters, just let us know, because it's very interesting. That is not meant to be a security protection, but it's more like a challenge. Let's just try to break through it and create some new rules that also handle those specific case scenarios. So thank you, everybody, and if you have questions, just go ahead. Thanks. How we are with time? Good.
What about questions?
Hello, my name is Stanislav. Thank you very much for your work. It is an excellent idea. I want to ask you what database supported by this solution for now?
As a backend?
What types of the databases? MySQL, PostgreSQL?
Inside the proxy or as a backend? So as a backend, only MySQL and now ClickHouse. And there are plans for supporting others, but somewhere in the future without any specific timeline.
Thank you.
Yeah, hello.
Hi.
I've got a few questions. First series about ClickHouse. Does these query replacements, the rules, they work for ClickHouse as well? Like we can obfuscate data with ClickHouse.
That's a very interesting question.
Yeah, because like I have tons of use cases where that would be great.
Let me see. Let me try to think if there is a slide in which I can actually physically show, but I don't think I have. So think to it this way. So the ClickHouse module for ProxySQL is very simple. Every time that comes to the ClickHouse module in ProxySQL, it's forwarded to, is transformed and sent to ClickHouse without any transformation. But you can always have, I don't have the slide for 2 layers. You can also have 2 layers of proxy. So you can have one proxy that does the transformation and sends the query, the MySQL query, to the second server, to the second proxy, and the second proxy will get the query that is already transformed, and it will send this query transformed to ClickHouse. So you can do this. You have to use 2 proxy. I will get soon there. So you have to use 2 proxy, basically one that does the transformation and the second proxy that sends the request to ClickHouse. Now, do you really need 2 proxies? No, because what you can do is that you configure ProxySQL, and then when you configure the backend for ProxySQL, you can configure ProxySQL itself as its own backend. So what happens is the traffic hit the proxy, goes out and come back into the proxy, and then goes to ClickHouse.
Okay,
just become complicated to pictures, but can be done.
I understand, but okay, just a follow-up question: how complex is this configuration? How?
Because the ClickHouse module in ProxySQL is on a different port, so what you have to do is just to configure as the backend 127.0.0.1 and the port where ProxySQL is listening for the ClickHouse module. So it's not complex at all. It's more complex to picture it than to actually do it.
Another question about ClickHouse. Just ClickHouse is the popular solution. It uses HTTP to communicate with clients. Like there are dozens of clients on the documentation website. ProxySQL does not use HTTP. No. The native.
It uses
interface.
It uses the C++ library.
Okay.
It's the same library that is used by the ClickHouse client, the command line one.
Yeah.
That one.
Okay. Last question about rules, and could you show the first picture of the where the servers are?
Oh.
Yeah.
This one?
This one. There were 3 machines. Each has ProxySQL. Is there some tool to, like, I would like to have the same rules on each machine, but I'd like to change them from time to time? Is there a tool or something?
Okay.
Graphical interface.
From the very beginning, the idea was to have the proxy to be easily configurable. So there is this admin interface when you connect and execute queries. The queries that are then transformed into rules. So assume that you have some console from where you can send the same query to all of them. This is option number 1. Option number 2, if you have some configuration management, Puppet, Chef, you name it, whatever. That's actually used by multiple users. What they do is you change the Puppet module and configuration file, then Puppet push to all the proxies and is automatically loaded. And then there is another option. There is this native clustering. So in ProxySQL 1.4.2, there is the clustering solution that was introduced. So now all the proxy are monitoring each other constantly. They're just exchanging the checksum of their configuration. So very small exchange of data. Doesn't use a lot of bandwidth, and when they detect that the configuration of one of them has changed, they open a connection and pull the configuration. So what will happen is you can connect to this one, create a new rules, and in a short period of time it's configurable how frequently they check. Those 2 will detect that this one has a newer configuration, that the epoch time on this one is higher than those. This means that the configuration there has changed after. So they assume, okay, this guy has a newer configuration. They connect to it and pull the configuration.
Okay, thanks. No, really, last question.
I'm fine. This guy might not be happy if jogging.
Native clustering and ClickHouse. Is it possible to make it work? Is there
The native
CMT?
clustering currently support 4 type of module in ProxySQL.
Mhm.
There is the user. So if you change one user in one of the servers, propagated everywhere.
Mhm.
MySQL server, query rules, and ProxySQL servers. That is basically the same backend technology used to detect one. The ClickHouse is still not there, but the point is that the ClickHouse configuration is not complex right now, so there is no need for the clustering solution. Something that can be implemented, but there is no strong need for it.
Okay, thanks. Thank you.
Hello.
Sure.
My name is Nick. Thank you for the presentation, and I have 2 questions. The first is the ClickHouse, is a sort of special database which is not so popular as MySQL, and why we decided to support it?
Okay, that's a very good question. 10 minutes for okay. So the reason why is to avoid actually, let me rephrase it, to improve the adoption, because currently if you want to use ClickHouse and you have an application that does not support ClickHouse, you have to make some change in the application to be able to communicate with ClickHouse. But if you have an application that is already speaking with MySQL, like if you have a PHP application, what you can do is to use instead of connecting to MySQL, you connect to ProxySQL, and ProxySQL will forward the request to ClickHouse. So you don't need to make any changes in the application.
What can you do with differences in SQL dialect of ClickHouse? There are a lot of operators such as exact, for grouping, dictionaries, and so on.
Yeah. Okay. So ProxySQL convert the query in the ClickHouse format and send it down to ClickHouse. So the dialect doesn't really matter. So if you execute the ClickHouse dialect, everything is fine. The problem is the opposite. If the client sends MySQL dialect that ClickHouse does not understand, and there has been work done there because now ProxySQL has some built-in rules that says every time the client is sending a query on information schema, for example, to get the char set, there is no such thing in ClickHouse. So ProxySQL just has to make up a result set and send to the client just to make the client happy. Otherwise, some client will throw an error.
So it's very difficult or impossible to use ClickHouse dictionaries.
Yes, you can. The problem is the opposite. If the client is sending MySQL specific queries, like specific one, like for example querying information schema, that does not exist in ClickHouse. But if you use ClickHouse dialect, that's absolutely fine.
Okay, I see. And another one, are you planning to support MS SQL? Microsoft SQL.
Oh,
Oh, I see.
I have no idea about the protocol.
Sorry?
I have no idea about the protocol, so it's something that I should
appropriate,
study.
yeah. I see.
I don't think it's impossible, but I honestly have no idea.
But,
it's something that I haven't looked into it.
Okay, thank you.
It also depends from the demand. If people start saying, well, it would be nice that ProxySQL support MySQL, and it's not just one person or 10 person asking for it, but there is critical mass asking for it. Yes, it makes sense.
But there are a lot of applications use ODBC connectors to use MySQL, MySQL, and so on. So can your product can support ODBC? So it's a very generic protocol.
I should look into it.
I think.
I should look into it and figure out how easy or difficult it is.
Okay. Thank you very much.
Thanks for the suggestion.
So does the rules cover joins or unions? The masking rules, I mean.
For the filtering, the one specific we show here, or in
if
general?
there is a union or join in a query, will the field be masked?
Yeah, I don't see why. I mean, if you see queries like this one, not going to. Oh, actually, let me go for a rule. Yeah. So if you have something like this,
Okay.
it doesn't really matter if you have complex join
Okay,
after. It will just match and replace. Actually, this one is not the best example. This one should be.
Okay, thank you.
This is the one that actually does the transformation.
Hello, Rene. Thanks for the talk.
Thanks.
I think you've been asked this question before, but anyway, have you ever considered replacing regular expressions with with an actual SQL parser? Because it sounds like a lot of complexity and some limitations come from the fact that ProxySQL doesn't actually understand SQL, right?
Yep.
So if you had
There is some plan for it.
oh, thanks.
Not well. The timeline is not defined yet.
Okay, cool.
It's not an easy task.
I understand, yes, but that would also simplify a lot of things
Yeah.
for users, right?
Yep.
Thanks.
Hello, thank you for your talk. I wanted to ask if it's possible to to apply rules based on the query plan rather than some regex patterns.
No, this actually basically is a follow-up on Alexei's question because it
sorry.
doesn't have the query. Actually, the query plan cannot get it.
Or
because the
is
query
it
plan
maybe planned?
I mean,
to
the
do in
idea would be
future?
like, for example, to replace the column name, a specific column like a first name, as a column name and not as a string. So yes, there might be some plan in the future, but again, timeline is not defined. But thanks for all this question. It means that there is the demand for it.
Well, I have some thoughts about it. Maybe it's very convenient to use in such cases as supporting legacy systems when you can rewrite some parts of SQL queries. So can we really replace one part query by another?
Yeah, I mean, you have regular expression and you can, I mean, you have the back references. This is what you mean, right? Like this /word means the last part. I mean, you use back reference in regular expression. So yes.
Mm-hmm. Thank you.
Any other question? As we have a few more minutes, if you want to have some question about other features, just raise your hand. Yeah.
I really about debugging of how the rules work. Like for example, I'm a client. I write in SQL and I get some result, and I cannot really understand why I got this result in this way, obfuscated or whatever. How would I be able to debug what exactly happened with my query?
Okay. There are some data that is being exported. For example, in the real-time statistic. In real-time statistic, one of the things that you get there is how many times that specific rule has been hit. So you know how many times the rewrite happened. And another thing that you can use is the I don't know where it is, the mirroring. So the query mirroring. So if you want to do a rewrite and you want to test it, you don't do the rewrite on production. So you can create some mirroring like a testing server, and you rewrite the query and send it somewhere else, just to see if the query is executed correctly. The proxy will collect metrics about this, so it will know. You will know from some statistic table how the query has been rewritten. So you will get this information. What you don't get is the result set. Okay. So the results that you won't get metrics from the proxy about the result set, only from the query. So you will have the original one, the modified one, and you will also know that it errors or not, because if it errors, you will have errors in the MySQL error log, and that's it. And also in the ProxySQL error log, because if the query fails, like you did some mistake in rewriting the query and it creates some syntax error, ProxySQL will generate an error in its own error log, so you know that the error was bad.
Okay. But is it possible to like enable the debug and logs, like detailed logs?
Now, what sort of extra debug information would you like to see? Like,
On the other hand, yeah, you're right. It's like
no, I mean,
No.
I'm asking like if there is a feature request. I'm not saying that this does not make sense, but more like what can be improved.
actually, I didn't have a proposition. Maybe I'm just used to like raw logs and
Yeah.
seeing them, and maybe that's it.
You get this information in ProxySQL
from
log. I think
statistics
that those
point,
are
yeah,
enough.
yes.
But if you think they're not enough, just let me know, and I will see how to improve those.
Thanks.
Thanks.